Welcome to lesson 92 of algebraic concepts, inverse variation. Okay, so here's our objective, inverse variation, a hyperbola. If you remember back a couple lessons ago, we talked about quadratics. Well, this hyperbola is a little bit similar to quadratics. Well, the shape of it at least is. Asymptote. We had an asymptote when we talked about an exponential function. I did not say the word asymptote, but we will see it now. We'll see a example, a picture of it, and then constant variation. So this equation right here is key, and this is one we'll be using for the day. Y equals k over x. Okay. Now, we dealt with direct variation when we were looking at proportions, and we know that y equals kx is direct variation. But now, indirect variation, the x is in the denominator or down bottom of a fraction. So that is the big difference between direct variation and indirect variation, or inverse variation. Okay, so now let's look at these dotted lines. This is what I want you to pay attention to. These dotted lines right here. X equals 2. It's an asymptote for both graphs, this one on the right and this one on the left. That means the graph will never touch x equals 2. You cannot go below it, cannot cross it, cannot touch it. And the same thing here. For the left side of this, the negative side of this function right here, it does not touch or go above 3. For the low side of the positive of this function, it does not touch or go below 3. And so let's deal with our first example. We know that we're dealing with inverse variation. X varies inversely with y. When x equals 4, y equals negative 3. What is the value of y when x equals 9? So with inverse variation, y equals k over x. So let's find our k. They give us negative 3 over k times x is 4. So now we had to solve. We multiply both sides by 4. Negative 12 equals k. So now that we know what we're working with, we use the equation again. Y equals k over x. What is the value of y? Y equals negative 12 over 9. And we get, let's reduce this fraction down, negative 4/3 equals negative 3 1/3. And that's the value of y when k is 9. Okay, let's look at example 2. Y equals k over x. Well, we're going to find the rate of change here. And so we don't really need to use this equation here. But if we do 9 divided by 3, we get 3. 6 divided by 2 is 3. 3 divided by 1 is 3. Is 3. Is 3. Is 3. The rate of change is the same everywhere. It's not changing. This table is direct variation. It is not indirect variation. So, no. So, no is the question. Because the rate of change is the same everywhere, it is direct variation. Okay, let's look at example 3. A homeowner will pay workers 1,000 hours to paint his home. Is this an inverse relationship? So we got workers, we got pay, and what do we have? let's let the pay is 1,000 over the number of workers. So yes, this is a variation. Yes, this is inverse because the pay stays the same. So if it was one painter, it'd be $1,000 divided by one. If it was two painters, it'd be $1,000 divided by two. If it was three painters, it'd be $1,000 divided by three. So the difference or the rate is changing for each amount of painters. So the more painters there are, the less the pay will be. Okay, let's look at example 4. So write an equation for the graph. We got y equals k over x. So our y is current, our k is k, and our x is resistance measured in ohms. So let's see if we can find this. So what you want to do is find a point that goes through the corner of a graph. This point is the closest one that goes through the corner of a graph. So we'll call this 5, and we'll call this 25. And so the point 25, 5. So let's see. If I stick the numbers in, 5 equals k over 25 multiplying 125 equals k. So now current equals 125 over the resistance. So those were our examples. We have 4 of them. Please try the practice problems that are coming up on the next couple of slides, and I will see you at the end of the video for a review or recap. Write an equation relating x and y when x equals 2, y equals 1/2. So we know that y equals k over x, when y is 1/2, x is 2. So if we cross multiply that, multiply by 2, k equals 1. So y equals 1 over k. X, I'm sorry. Y equals 1 over x. Okay, that's our equation. All right, so we got 12, we got 3. 4 divided by 3 is 1.3. 3 divided by 4 is 0.75. 2.4 divided by 5. 0.48. It's not quite half. It's a little bit more than half of 75. But this is going down. This does show an inverse relationship because the relationship between the variables is constantly changing. So, yes. Okay, explain why the relationship is inverse. The length and width for rectangles of an area is 36 square centimeters. All right, so let's draw a rectangle. And the area inside is 36 centimeters squared. Okay, so let's call this the length and this the width. So what you have to imagine is if you change the width, if you make the width longer, then the length has to get shorter because we're dealing with the same area. So basically this was a thought. So it gets wider, but then the length shrinks. The length shrinks. So you can't make both of them bigger. If one gets bigger, one has to get smaller. So let's put some numbers in here. Let's call this 8 and let's call this 4. If we increase the width to 6, then, wait, no. I'm sorry, that would be 9. 9 times 4 is 36. So the length has to be 6. Or what we could do is make it real long. And then the width becomes 9 and the length becomes 4. I know that doesn't look like 4. Let me make it better for you. Let's try this. This might look better for you. And that might look like 4 to you. So you still had the same area. I didn't draw the middle one to scale, but this is freehand. So if the area stays the same, as one goes up, the other one goes down. And that's called inverse relationship. Okay, write an equation for the graph below. So let's see what we got here. We know that y equals kx. We're looking for the dot that's closest to the corner of a graph. So this one is closest to 5 over 100, which reduces down to 1 over 20. I'll leave it at 5 in 100. I don't know why I'm reducing it. So when the y is 5, the x is 100. So that gives you 500 equals k. So we got y equals 500 over k for mass versus change in temperature. So the more mass an object has is slower in changing temperature. That's what this graph is telling us. Okay, so that was this lesson. Thank you for watching. And if you like what you saw, please subscribe, hit that notification bell. More videos will be coming, and I will catch you on the next video.